notes for tonight, notes 11-18, solving systems by substitution. Please put 318 as your date, and this is page 72. Take notes on your handout and follow along with the examples. Pause the video at any time so that you can try a question on your own. So here we go. For substitution, we're looking to have y equal to something or x equal to something. And in this case, we have the expression 2x minus 1. So wherever we see a y, we're going to put the expression 2x minus 1. We're going to follow our distributive property, combine like terms, etc. for all of the solving equation steps. So here we have 4x plus 3 times y, but y is now 2x minus 1 equals 27. I'm going to use the distributive property, and so I have 4x plus 6x minus 3 equals 27. Combine my like terms so that I have 10x minus 3 equals 27. Add 3 to both sides. So 10x equals 30. Clear my coefficient, and I have x is equal to 3. But now I need a value for y, because in the end I am looking to have an ordered pair where these two linear equations cross at one single point. So y is equal to 2 times x plus 3 minus 1. So we have y equal to 6 minus 1, which is 5. So the ordered pair that I am looking for is 3, 5. Moving on to example number 2. They don't have an equation here that gives me x equals or y equals, but I can rearrange this equation by subtracting a 2y from both sides. I get x equals 2 minus 2y. I'm going to use this expression 2 minus 2y to plug it in when I see an x, for example, right here. So I have 3 times x, which is now 2 minus 2y, minus 4y equals 26. I'm going to use my solving equations property or steps by distributing the 3 and getting 6 minus 6y minus 4y equals 26. Combine like terms of negative 6y minus 4y. So I have 6 minus 10y equals 26. Subtract 6 from both sides. So negative 10y equals 20. Divide by negative 10 from both sides. And I get y equals negative 2. So my ordered pair is going to be something, comma, negative 2. And so I have x plus 2y equals 2. I have the value now negative 2 for y. And I need to know what value for x will work so that something plus a negative 4 will give me a positive 2. And that value for x is going to be x equals positive 6. So our ordered pair is 6, negative 2. That's where these two linear equations, the original equations of the example, cross. Example number 3 says y is equal to x for this one. So wherever I see a y, I'm going to put an x. So I have x plus x equals 14, which means I have 2x equals 14. Divide both sides by 2, and I get that the x coordinate is 7. So I have 7, comma, something. So what plus 7 is going to give me 14? That answer is 7, and it's also because x and y are the same value. So that was an easier question, or easier example. For example number 4, we have 4y is equal to negative 3x. And I'm going to divide both sides by 4 so that I have y equals negative negative 3/4 x. And wherever I see a y, I'm going to put negative 3/4 x. So I have 5x plus 8 times negative 3/4 x equals 4. I have 5x minus 24/4 x equals 4. Well, 24/4 is just 5x minus 6x equals 4. So I have a negative 1x equals 4. And if I divide both sides by negative 1, I get x is equal to negative 4. So if that's the x coordinate, what's the y? Well, you can go back to the original, 4y minus 3, or equals minus 3x. You can put in the negative 4 for x. I get 4y is equal to positive 12. Divide both sides by 4, and the value or coordinate for y we are looking for is a positive 3. So those two equations will cross at negative 4, positive 3. That is substitution and solving linear equations. Please bring these notes with you to class on Tuesday. I think I got behind in my talking. Change these notes to the 9th, but it is still page 72. Have a good night.